This is the day one of me approaching DSA on LeetCode. Although the journey will be long, it has to start somewhere. So let's begin. So I have been given the question, which is the age old and which is the basic question, that is to sum. So we have been given an array of integers num and an integer target, which returns indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. And here are some examples. The first example is 2, 7, 11, 15, which has the target element as 9. The output would be 0, 1, because nums 0 plus nums I 1 is equals to 9. Hence, we have returned 0, 1. Nums I is the target. Then return new integer array of ij. Let's see if this program works. Okay, then -1, -1. So here is my brute force approach towards the solution which I came up very early, which is not the optimized. I know that the optimized solution will be coming up in the next section. This is just my brute force approach towards it. Let's see if this runs. Okay, this is running. Let's submit it and see what is band complexity, what is space complexity. So this question beats just 5% of the total submissions. Let's analyze complexity. O of 1. O of n squared. Since there are two for loops involved in this, the time complexity has raised up to 2 degree. And since there is creation of no new array, the space complexity is O of 1. So let's see what the optimized solution for this question is. So now I will be writing the most optimized solution, which will be taking the time complexity O of n and the space complexity as O of n as well. So we have to create a hash to serve this purpose. Yeah, integer. Let's name it that, and and let's make a complement variable which will be storing the complement of the target value, which will be equal to target minus nums I. Let's initiate a for loop to traverse throughout the array. I is less than nums dot len I plus plus. Oh, sorry, then complement shape is stored and created inside the for loop so that its value changes with every iteration, and we will compare if the complement lies within the map hash map that we created. So we'll check whether the complement is a part of the hash map or not. If it is present, then we will return key and its value. Sorry, I mean integer which contains two elements. The first one being the complement's value, which is inside the hash map, and the second element would be just the index that is currently in the iteration right now. So map get complement I, and if it is not present, we will just simply add the current iteration element inside the hash map. So the code goes as map dot put current element, which is nums I, along with current index. And if we do not find any match, we just simply return an array which contains -1, -1, so that our code doesn't break. Let's test this. So you can see our code successfully runs. So let's submit and see where our code stands. So this is the most optimized solution, as I said, because the space complexity of this is O of n, which is due to the fact that we have used an hash map, and each element inside the array, which we have taken as nums, either the element gets mapped inside the array, or also to the hash map, or it gets returned midway during the execution of the code. So the worst case scenario is O of n time complexity and space complexity. And talking about the time complexity, since each operation that happens on the hash map, it can be either lookup, which takes O of 1 time complexity on average, or it can be insertion, which takes O of 1 time complexity on average. So the amalgamation of these two elements results in a time complexity of O of n, which is directly proportional to the n elements present inside the nums array. So this is the justification of the time and space complexities, and this is the first solution. Bye bye.